Hello everyone, myself Jayanth. Welcome to another video. I am currently pursuing my BE in Sri Venkateshwara College of Engineering. The subject is Introduction to Civil Engineering and I am currently studying in second semester in the section Devo. The topic which I am going to discuss today is wastewater treatment plant and its process. First, let's know what is wastewater treatment plant. A wastewater treatment plant is a facility designed to receive, treat and process wastewater from various sources including residential, commercial, industrial and institutional activities. The primary purpose of wastewater treatment plant is to remove pollutants, contaminants and pathogens from the wastewater before discharging the threat effluent into the environment or reusing it for beneficial process. Wastewater treatment plants employ a combination of physical, chemical and biological process to treat wastewater including screening to remove large debris, sedimentation to settle out suspended solids, biological treatment to degrade organic matter, filtration to remove fine particles, disinfection to kill pathogens and sludge treatment to manage the solid residues generated during treatment. The steps involved in operation of wastewater treatment plant they typically include the following process: preliminary treatment, primary treatment, secondary treatment, tertiary treatment and sludge department and disposal. Let's know about preliminary treatment. Preliminary treatment is the first stage in the wastewater treatment process, focusing on the removal of large debris and solid materials from the incoming wastewater. This stage is crucial as it prevents these materials from damaging or clogging downstream treatment process and equipment. Here's a closer look at the preliminary treatment process. Let's discuss about the steps involved in preliminary treatment. The first step is screening. The incoming wastewater passes through a series of screens or gates designed to capture large objects such as sticks, racks, plastics and other debris. Screens are typically made up of metal bars or mesh with openings of varying size to trap different types of solids. The trapped solids are collected and removed manually or mechanically using rakes or conveyor belts. Grit removal. After screening, the wastewater may undergo grit removal to eliminate heavier inorganic materials such as sand, gravel and grit. Grit can cause abrasion and damage to pumps, pipes and other equipments in the treatment process if not removed. Removal system use gravity setting or mechanical methods such as aggregate grit chambers or vortex separators to separate and remove the grit particles from the wastewater stream. The removed grit is typically washed, dewatered and disposed of in landfills. The third method is flow equalization. In some wastewater treatment plants, flow equalization may be employed as a part of preliminary treatment process. Flow equalization helps to smooth out variations in wastewater flow rates and concentrations, providing more consistent conditions for downstream treatment process. Equalization basins or tanks are used to temporarily store and mix incoming wastewater, allowing for gradual release to the treatment system. Trash rack. In local prone to accumulation of large floating debris such as logs or vegetation, trash racks may be installed upstream of the screen to prevent blockages. Trash racks consist of bar or gates positioned across the flow path to trap the divert large floating objects away from the screens. Let's know about primary treatment. First of all, what is primary treatment? Primary treatment is the second stage in the wastewater treatment process following preliminary treatment. It involves the physical separation of suspended solids and the partial removal of organic matter from the wastewater. Primary treatment typically takes place in large tanks called primary sedimentation tanks or clarifiers. Here's an overview of the primary treatment process. The steps involved in the primary treatment process are flow of primary clarifiers. After preliminary treatment, the wastewater flows into primary clarifiers, also known as sedimentation basins or settling tanks. These tanks are designed to allow wastewater to flow slowly, providing sufficient detention time for gravity settling to occur. Second one is gravity settling. In primary classifiers, the flow velocity of the wastewater is reduced, allowing suspended solids to settle out under the influence of gravity. Heavier solids such as grit and sand and organic particles settle to the bottom of the tank and form a layer of sludge, while lighter materials float to the surface as scum. The sludge accumulates at the bottom of the tank, forming a layer known as primer sludge, while the scrum is skimmed off the surface and removed. The third process is sludge removal. Mechanical scrapers or suction devices are used continuously or periodically to remove the settled sludge from the bottom of the primary clarifiers. The collected sludge is pumped to sludge treatment process for further treatment and disposal. After the sludge removal process, there comes effluent collection. The clarified wastewater, now significantly reduced in suspended solids contents, exits the primary clarifiers through effluent wires or channels. The collected effluent is then directed to the next stage of treatment, usually secondary treatment, where biological processes further remove, dissolve and colloidal organic matter. Let's know about secondary treatment. Secondary treatment process is the next stage in the wastewater treatment process following primary treatment. It focuses on the biological decomposition of organic matter and the removal of dissolved and colloidal pollutants that remain in the wastewater after primary treatment. Secondary treatment utilizes microorganisms to metabolize organic pollutants, converting them into simpler, more stable forms. Here is an overview of the secondary treatment process. Let's know about biological treatment methods. The most common method of secondary treatment is the activated sludge process, although other biological treatment methods such as trickling filters and rotating biological contractors are also used. The second is activated sludge process. In the activated sludge process, wastewater from primary treatment is mixed with a culture of microorganisms in aeration tanks. Oxygen is supplied to the aeration tanks to support aerobic conditions, promoting the growth and activity of aerobic bacteria and the other microorganisms. These microorganisms use the organic pollutants present in the wastewater as a food source, breaking them down into simpler substances through biochemical reactions. The wastewater and activated sludge mixture, known as mixed liquor, undergoes intense agitation and aeration to ensure effective contact between the microorganisms and the organic matter. The next process is clarification. After the biological treatment process, the mixed liquor is allowed to settle in the secondary clarifiers or sedimentation tanks. Then the settled biomass is recycled back to the aeration tanks to maintain the population of microorganisms and continue the treatment process. A portion of activated sludge is wasted from the system to control the sludge concentration and maintain optimal treatment perform. The next step is effluent quality. Secondary treatment significantly reduces the concentration of organic pollutants, suspended solids, and pathogens in the wastewater, producing a cleaner surface. However, some dissolved pollutant nutrients and residual organic matter may still remain in the effluent after secondary treatment. Now let's know about tertiary treatment. Tertiary treatment is the final stage in wastewater treatment process following primary and secondary treatment. It involves advanced treatment process designed to further polish the treated effluent and achieve higher levels of purification. Tertiary treatment targets the removal of remaining pollutants, pathogens and contaminants to produce effluent of higher quality for specific reuse applications or strengthen discharge standards. Here is an overview of the tertiary treatment process. Filtration is a common tertiary treatment process used to remove remaining suspended solids, fine particles, and colloidal matter from the treated wastewater. Various filtration technologies may be employed, including sand filters, multimedia filters, membrane filters, such as microfiltration, ultrafiltration, and reverse osmosis, and granule media filtration. These filtration systems operate by passing the treated effluent through porous media or membranes where suspended solids and particles are physically retained, resulting in cleaner effluent. Chemical precipitation. Chemical precipitation is a process used to remove dissolved pollutants, metals, and nutrients from the treated wastewater through the addition of chemical coagulants and flocculants. Coagulants such as aluminum sulfate or ferric chloride are added to the wastewater, causing suspended and dissolved particles to aggregate and form large flocks. Flocculants such as polymers are then added to enhance the agglomeration of particles and improve their settling characteristics. The formed flocks settled out of the wastewater as precipitates along with the trapped pollutants, leaving behind a clarified effluent. Let's know about the sludge treatment and disposal method. Sludge treatment and disposal are essential components of wastewater treatment plants to manage the solid residues generated during the treatment process effectively. Sludge, also known as biosolids, is composed of both organic and inorganic solids separated from wastewater during primary and secondary treatment. Proper treatment and disposal of sludge are crucial to minimize environmental impacts and comply with regulatory requirements. Here is an overview of sludge treatment and disposal methods. So these are some of the advantages and disadvantages of wastewater treatment process. Advantages are environmental protection, public health improvement, water resource conservation, compliance with regulations, resource recovery, economic benefits, community well-being, sustainable developments. The disadvantages are high capable and operational cost, energy consumption, sludge management, chemical use, greenhouse gas emission, land and habit impacts. This was all about wastewater treatment and processing. Thank you for watching the video.